Jai Jinendra, Namaste. My name is Sayyam Jain. Welcome to my channel. Today we are going to solve the 18th question of the problem solving series that is based on arrays. So we need to find the majority element, and the majority element in this case, it should be greater than the number of occurrences of that element should be greater than n by 3 times of the total number of elements. Like if there are 9 elements, then the majority element should be at least greater than 3. So the difficulty level for this question is medium, and this question has been asked in Amazon, Microsoft and few other companies as well. So let's discuss the example first. So we have already discussed the 17th question, the previous video. We have discussed the majority element which is greater than n by 2. So we have already discussed the Moore's voting algorithm. So we will be using the same logic. So if you have not watched the 17th video, please go and watch that video. If you want to know about the Moore's voting algorithm, so you watch the previous video. So I'll be explaining it again here. So here we have six number of elements. So the majority element should be greater than 6 by 3, that is 2 times, at least it should come 2 times. So we can see here 10 is coming 1, 2, 3, 4 times. So 4 is greater than 6, right? And is equal to 6, and 4 is greater than 6. So the answer will be here 10. In this second example, we have 3, 4, 5, 6, 7, 8, 9. 9 elements. N is equal to 9. So the majority element should be greater than 3 times. It should come more than 3 times. So we can see here the 20 has come 2 times, 10 has come 2 times, and 5, 4, 1, 2, and 30 have come 1 times. So the element has come 2 times, majority element has come 2 times, but it is not greater than 3. So we don't have any majority element here which is greater than n by 3 times, whose occurrence is more than n by 3 times. So the answer will be -1. So in the previous video we have seen that we can solve the occurrences question using sorting algorithm, hashing. We will sort this and we will find the number of occurrence of the maximum number of occurred element. We will get how many times if it has occurred, and we will check whether that occurrence is greater than n by 2 or not in previous video, and in this case we will check in this question we will check whether it is greater than n by 3 or not. If it is greater than n by 3, then we will return it. So we can solve it in order of n log n if you use sorting. If you use hashing, then we can solve it in order of n, but we have to use extra space of map or set of order of n, where we will if you use hash map, we will have the frequencies of all the elements, and whichever element has occurred most number of times, we'll check its frequency, is it greater than n by 3 or not. If it is greater than n by 3, then we will return that. So how do we use Moore's voting algorithm over here? In the previous video we have used it, so we had to get only one element. Here at least there is a chance that n by 3, right? So this n by 3 can actually come 3 times, right? There could be 3 elements. There could be at least max. There could be 2 elements which have come more than n by 3 times, right? Because if n by 3 means 1/3 of the arrays will be having that value, right? That element. So there could be 3 such pair, right? For example, here there could be 210, 220 and 230. So if that is the case, we don't have any element which is greater than n by 3. So maximum it could be, there could be 2 such pairs whose occurrences are more than n by 3, and the rest may not be there, right? So we can have maximum 2 such elements. We need to return one, or if we need to return it to 2 such elements, then we can return it as a vector or a pair, whatever we want. but it is given probably in the question that we need to return any one such majority element. So the point is, the intuition for this question would be that there could be only one such pair which could be more than n by 2 times, right? But here in this case there could be two such pairs which can be more than n by 3 times, right? Majority in the n by 2, like n by 2 is half and there is other half. So to be the majority element, one element should be more than n by 2. So there is only one such element. So we were returning that element. But here n by 3. So n by 3, n by 3, n by 3. So if there is a chance that there can be two elements whose occurrences are more than n by 3. So we will take two such elements. We will use the same logic and we will use the same Moore's voting algorithm. But we will have two such values like majority element, two majority element, first and second, and we will have two counts and we will count it and we will use the same way we have in the previous video what we have done. We will do the same thing, and then once we have the two candidates which could be a majority element, then we can check whether its count is actually greater than n by 3 or not. Let's code it. We'll take first the element first, second, both assigned to int max, and we will have count 1 and count 2 both assigned as 0, right? Then we will traverse the array. Then here whenever we are traversing, so assuming that we have got in the beginning the count would be 0. So when we see the count 1 is 0, whatever the first element will get, we will make the first element as the AI as the A0 as the first value, because we don't have any such value. The same way we did for the n by 2 thing, same way we will do, but we will first write this condition that after all those things, right, in the beginning only we will write that if first equal to AI, assuming we have already got the first element in the beginning, so this condition has to be written first. So if first equal to AI, then we will increase the count 1 simply. Else if we have the second element as the AI, second equal to AI, then we will increase the count 2. Else if both the condition is not there and we see that the count 1 value is 0, then we will assign first as the new value AI and we will increase the count 1 value. Else if count 2 equal to 0, then we will do the same thing. We have the new second element AI and count 2 would be plus, or else both count 1 and count 2 would be subtracted because none of them are come in the array, and we would have by that time we would have got the first and the second elements, and then we will make the count as count 1 equal to 0, count 2 equal to 0, and now we will traverse the array and see the actual count of the first and second, 0 to n minus 1. If AI equal to first, count 1 plus, else if AI equal to second, count 2 plus, and if first is greater than n by 3, return first, else if second greater than n by 3, return second, else return -1. So we are done with the coding part. Let's dry run this code for this example. So initially we don't have the first and the second value, so it will directly come over here, and our first will become 10 and count 1 will become 1. First will become 10. Here again first is equal to AI, so count 1 will increase. So C1 will become 2 and our first is 10. Now here 20. The AI is 20 and first is 10, so this won't come. We don't have any second value right now. Count 1 is not equal to 0, count 1 value is 2, count 2's value is 0. So we will have the second value as 20 and our count 2 will increase. So C1 is 2, F is 10, but C2 becomes 1 and second becomes 20. Now we go over here 30. So AI is not equal to 30 is not equal to 10, 30 is not equal to 20, and both this condition has now doesn't satisfy, both count have the value. So we will be going to this condition where we will be subtracting both the cases. We don't have any of these two elements, so count 1 will become 1, count 2 will become 0 again, first is 10, second is 20. Now we get 10 out again, so count 1 value increases, and again 10, count 1 value increases again. So count 1 is here 2, count 1 is here 3, and we have count 2 as 0 only, and first is 10, second is 20. So count 1 is 3, we have the first value as 10, we have traversed the loop, and according to this the first value is 10, so we traverse the loop again, we make the count 1 and count 2 0, and we traverse and we see how many times 10 has come, and the count 1 value is how much? 1, 2, 3, 4, and how many times second has come? Second is 20, so second's count 2 value is 1. So when we traverse again, we see here it is first greater than n by 3. 10 has come 4 times, and n is 6 by 3 2, which is greater. That's why our answer is 10. So in this way this code works. I hope the solution is clear. If you have not understood this, then please try to see the previous question where I have explained the Moore's voting algorithm in details. And I think this here also I have explained it, and this should be clear. The link to the question has been given in description. Please try the question yourself, the solution yourself, and then come to my code walkthrough section.
Here is the code walkthrough of the second part of majority element, the 18th question, where we need to find elements whose count is more than n by 3, and this is the implementation. So here we are getting the count of the first and the second. If we don't have, the count has become 0, we take the first element again, and if the count 2 is also 0, then we take the new element as the second element, we increase the count. And if we said that the count is also not 0 and we don't have the first and the second, then we obviously decrease it. So after this traversal, we'll have our first and the second candidate, and then we check, then we find the actual count of the first and the second candidate, and then we check if the count is greater than n by 3, then we push the first and the second element to the answer vector, and then we return the answer vector. Here the return type is has to be a vector, so we have implemented it this way. And you can see we have to implement it order 1 space, so we have not taken any extra space. This vector of int of answer is just the answer we have to return, so this is not the extra space. So let's run it. So we can see all the 3 test cases have passed, so let's submit this. So we can see the solution has worked. So the link to the question has been given in the description. Sorry, I meant to say that this let me know in the comment section how was the explanation, and see you all soon in the next video where I'll be explaining the 19th question of the problem solving series. Thank you. Jai Jinendra.